Well, good evening, my friends, and welcome to Environmental Coffee House. And I am Sandy Schoelles, and welcome Jim Massa, Science Talk with Jim Massa, oceanographer from Alaska, and Jennifer Hynes, my wonderful partner, my partner from Colorado in so many ways. Welcome. We have a pretty good show tonight. I Well, we're going to talk about the little bit of the controversies in the science community. We're going to talk about the polar vortex. We're going to talk about the freezing, some old research, and I'm going to hand it over to Jen to do a little pre review, and then we are going to get started. So, welcome, Jim, and hi, Jen.
Hey, hey guys. Good to see you tonight, Jim. I'm always so happy to be on with you and Sandy.
Absolutely.
Thank you.
So tonight we have a pretty interesting show. Well, it's great to have you here, all the way from Alaska as well. It's amazing, the miracle of modern science, right, guys? Communication like never before. So tonight we're going to be talking first and foremost about Michael Mann. You all might have noticed that Michael Mann's been in the news a whole lot lately, and he actually did just stream live today on Tom Hartman, and I watched that show and saw it live and saw Sandy there in the comments. We're going to take a look at just different aspects of what he says and turn it around in our heads. Then, top of the news has been the polar vortex and the extreme weather in the United States. So we're going to be talking about that and the science behind that. As well, we're going to talk about the Arctic, and we're going to talk about how's the Arctic warming linked to the polar vortex and other extreme weather. Then hopefully we'll have time cover some events, extreme weather events that are happening around the world right now. First and foremost, Texas. The massive Texas gas failure during climate extremes gets blamed on wind power. A lot of people in Texas, especially southern Texas, Galveston, were without electricity for several days. Other strange events, heavy snowfall, gales as winter storm hits the Middle East. Greece got a lot of snow as well, which hasn't happened. If we have time, then Sandy, I thought we'd talk about the Bill Gates article, the rise of the climate dude, maybe touch on that. And then if we have time, which I doubt we will, we may cover an article from Resilience. In any case, we'll put it in the show notes. So it's worth a read. Oh, it's really profound. It's called Worried About Earth's Future? Well, the outlook is worse than even scientists can grasp. And it's done, it's published with 3 people. Paul Ehrlich is one of the authors, and it's a profound and heavy article. So, guys, that is where we are going tonight.
And with you, Jim, we are going to give you the honorary Environmental Coffee House Welcome Flush. That flush represents a lot of good things for us. All right. So, Jim, tell us how you've been and actually start us out with your last video on Science Talk with Jim Massa. Maybe just do a little recap of why we are where we are. And then I am going to discuss the reasons why I think, it's not I feel, it's from research, why Dr. Mann takes the positions he does. And take it away, Jim.
Yeah.
Well, the last 2 videos I posted to my channel, the first one was talking about why stable oceans are a bad thing for the planet. And in the video, Michael Mann was featured a bit in the article that I was covering. When I made that video, and I saw those comments by Mann, this is before he started making recent comments, including an extensive interview with Ira Flato on Science Friday. And some of the things he said on that program, well, it just kind of gobsmacked me. I almost drove off the road when I was hearing some of the things there. So I felt that, to put proper balance and perspective, I needed to make a video to address those comments. And basically, the essence of what he was saying, what I took disagreement with, was saying that if we went to zero emissions, we can cap warming to no more than 2 degrees C above pre-industrial levels. And he then went on to say that people who say that it's too late, there's too much thermal inertia, we're just a bunch of doomers.
Right.
And it's like, we're at 1.4, 1.5 now, and look what's going on. So to have another 0.5, shall we say, leeway would be disastrous. It will even be more crazy stuff happening in addition to what is already happening. And the thing about thermal, that's what kind of got me going. It's just like, you can't argue with physics. He's a physicist. He should know better.
Well,
And that's what I took extreme exception to. And yes, he's an atmospheric scientist. Yes, I'm an oceanographer. But it is very important to understand the role of the oceans in all of this. And the role of the ocean is a lot bigger than people are giving credit for. And I'm not just saying that because I'm an oceanographer. That's what's going on. That's what the data tells us of how much the ocean drive things. And yes, of course, it's coupled with atmospheric forcings. But as I stated in that presentation, there are models now saying we're going to hit 5C at a minimum. And most likely it's going to be in the 7 to 9C, if not 10, 11 by 2100. There are ecologists who say that if we go to 4C, humans go extinct.
Yes.
So if this continues, this is going to be the last century of humans, according to some of these scientists. Mm-hmm. So it was very alarming state of affairs. It really is.
Well, it
really is.
And I do agree with you.
Yeah. And I watched that live stream today that was on the Thom Hartmann show. Michael Mann was a special guest, I guess. He was kind of the central guest in the middle. And everything he said was true, but his language was cautious, and he seemed to be whitewashing things. And you know what I thought was really kind of hysterical? He lost connectivity at the very moment when Thom Hartmann brought up methane. I don't know if you noticed that. Remember, Sandy, when he lost connectivity? And Thom Hartmann was saying, and then all the methane in the Arctic, and then all of a sudden, and he really did, it just all went garbled, and then he had to reconnect and everything. And of course, the methane issue never came up again. I was like, darn, I wish I knew the answer to his question on that. I really want to see what he thinks about. Well, so much so that he made like the internet explode at that moment.
He made the internet explode.
If I can jump in a bit on the methane issue, there's some studies and basically pushing back at Natalia Shakova's and Igor Simotov's research, saying, "Oh, there is no time bomb. The leak is going to go on, for 100 years or so, whatever." 100 years geologically is nothing, so that is a bomb. It's just maybe not in the perspective of a human lifetime, but it is It's always, as I keep stressing, I keep coming back to this point. It comes down to the rate of change. That is the fundamental concept underneath all of this. So all this methane, and this, I'm seeing all sorts of crazy estimates out there. Some at least 14 gigatons of methane, and between ESAS, the permafrost, all over the place. If that all leaks out in 100 years, I call that a bomb.
Most definitely. I mean, how long did it take for the Permian mass extinction to have effect, right? That's the biggest extinction, 252 million years ago. And it had like the Siberian traps and all that. It's a huge amount of greenhouse gas seeping into the atmosphere quite suddenly. Even that, it took, 10,000 years or more to affect? Or how long, Jim? Do you have any idea on that one?
It was, well, are you talking about, when we started repopulating species?
No, I'm talking about like how much faster are we emitting greenhouse gases into the atmosphere than was done at the Siberian mass extinction by natural forces. And I'm just trying to compare them
I don't
because
have
my
exact.
my my premise
I
is
get
that
it.
this extinction is so much bigger and so much faster with so much more momentum, with so much more punch. But I can't really put any numerics on it, but you know,
But it's a
I would
different,
venture.
it's different. You know, they have the climate models. One of the things that Michael Mann, that Dr. Mann was working on way back was the climate models. And also there's also the recent was what bench line, you know, what's the bench line, what are they going to go down to, are they going to take pre-industrial, or are they going to take from the 19th century, which are more appropriate, which will show us the accuracy of the temperatures. It's all very interesting.
Yeah.
Well, one thing I've been
And
noticing
I'm
in a
going to
lot
put the
of
notes.
the graphics being put out lately is that there's a tendency to use the 1951 to 1980
Mm-hmm.
average as now the baseline, as opposed to the 81 to 2010, because then you see a more stark contrast between 70 years ago and today as to how much things are that much warmer.
Right.
Whereas, because things are warming, so if you keep moving the baseline, you like moving the goalpost, the temperature anomalies is going to be less, because the difference between 2020 and say 2010 is less than between 2020 and 1950. So now
Yeah.
I'm seeing more and more of the 51 through 1980 baseline being used for comparative purposes. As
Well,
far
do you
as the
think it'll
Permian
get
goes, I
better?
don't have exact numbers as the rate of extinction, but what's going on today is definitely a much, much higher rate for sure. I
Yeah.
mean, there's like a million species that we know of. I mean, we don't. There's so many species that are totally unknown to science, that have not been discovered or identified or described, that we're possibly losing. And
Mm-hmm.
so we toss in the 1 million that we know of that are endangered. It's probably about 10 times the amount. It's going to
No.
be considerably more. We're in the
Mm.
middle of a mass extinction event, and it is happening on a scale that is much, much faster. Uh, Elizabeth Kolbert wrote that great book, you know, the mass extinction, and
And
I
she has a
think
new one, Under a White Sky. Listen,
yeah,
I do have
it's
a little bit of housekeeping right away here. Right away, guys. If you want us to answer questions, put two Q's before your questions. So when I go back, I can find them, because it's really hard to find them. And I want the chat involved tonight. So I forgot to say that in the beginning. Um, so your last video was really, point on. You were confused, and if you don't mind, I might answer why I feel that this is how Dr. Mann is taking his path, and why he's taking the path he's taking. Okay? Ready?
sure
Yeah.
All right.
ready.
So first things I'm going to show you. This is Dr. Mann's Twitter. And it was funny because he had the three books up. Somebody else tweeted Bill Gates, How to Avoid a Climate Disaster, and then Colbert's Under a White Sky, The Nature of the Future. And I've heard her interview, and it was a good interview on public radio. And then The New Climate War, which I really want to read. I do. Now, it was funny because I didn't understand that how Dr. Mann felt about Bill Gates. And so his comment was, I am 67% in agreement with you, David. And I said, well, wait a minute. You don't like Colbert's assessment? And he had come back with, oh, no, that's a wonderful. He said, no, I'm wonderful. It was wonderful. And, in essence, that you have to read her stuff. And so there you go for that. But I'm going to go on, and what I really want to explain to you is the meat and potatoes of why he's not able or will not talk about the things that we know from all the research and all the other scientists. How many scientists signed off on the collapsology article that the LA Times put out about the calling the collapsologists. Well, but I will show you. As I was in academics, higher ed academics, and I was a research administrator. Well, University of Pennsylvania is a private institution, and it is very, very difficult to see who their donors are and where the money comes from. But what I am going to show you is a graphic, I mean a page, and it will explain a little bit why he is like he is, and it's because of where he works. It's This is the gifts, the charitable gifts, and being a private school, it's not all out in the open. Okay. Now they have IRS rulings and regulations that they have to go by, right? They absolutely have to go by. But what I want you to see is the categories: gift, charitable grant, unrestricted grant, restricted grant, and contract. And, you see that there is, like usual with all grants, there's a scope of work. There are deliverables for these fundings, but I worked in a public institution. It's a lot different. There are F&A costs, which are 15%, let's say. That's facilities and administrative costs to run the grant. Because believe it or not, guys, research administrators like me are critical. If it wasn't for research administrators, the principal investigators could not do the work that they do, because we did all the heavy lifting. From the administrators that worked with writing the grants to submitting the grants. But it's different in a private university. So what I am showing you here is that there's like typical payment mechanism, but funding restrictions. All right, let's say there's a private grant, a private unrestricted grant. It is limited to $100,000 per company, per PI, principal investigator, per year. Okay, so they can get that to run their. He has a center. I couldn't find who funded it, but you see, that's what I'm trying to tell you. There's grant agreements stipulating payment and other terms, or with a unrestricted, there's a company letter stating financial the way that the support is going to be. Or in restricted grants, the grant agreement stipulating payment, reporting, and other terms and conditions. And then there are formal contracts stipulating payment and all that. But basically, guys, what I'm saying is that the money in the private institution, the donor can actually, there are deliverables to a donor. And so if Michael Mann's funding, and I'm going to throw this out there because I couldn't find it, is, let's say, Ford Motor Company, and that is to assess the electric vehicle emissions and how they're going to be different. Don't you see there will be a conflict of interest if he starts to tell the truth? He can't. He is contractually obligated to the University of Pennsylvania, a private institution. The money is, the way they spend it, everything. It's very important. He's not, if he wants to stay where he is, and he has become quite a spokesman through his books, which I don't know who published them at the moment. I didn't have enough time. If they were published, if there was anything that had to do with the university, well, then of course that it was funded by someone while he wrote it, unless he took sabbatical to write the book. Michael is a PI. He runs a center. So how does he write a book at the same time? Is it funded by somebody? So my theory, and it's not anything unusual, and it's not bad. I mean, it's not horrible. It's what happens in academia. He cannot talk about anything except what is appropriate for his position and his research. And the research is all on there. I looked, his research was wonderful. And his ocean research on stabilization, how that's not a good thing, and all of it. So basically, this is my piece to tell you and be devil's advocate. He's not going to talk about the methane. He's not going to talk about scaring anybody. And my bet is dollars to donuts, since he is a esteemed scientist, that he's probably working with the Biden administration in some kind of advisement role. It could be on a donor. It could be the federal government is giving a certain amount of money to the school. I don't know. It could be anything. But I do believe he might be working as an advisor to Jennifer Granholm in the Department of Energy, because the focus is electric cars, and that is huge. And Michael's thing is to become zero carbon, and that's where he wants to be. So when he details, and again, I didn't read the book yet, I've just looked at the pieces, and he details the climate inaction people, the inaction people, the people that are saying there's nothing we could do. He's saying, well, no, there's a lot we can do, and we should be doing it. And I am a firm believer that we should be doing things also. I don't say I'm not going to sit back and do nothing, but that's my little piece. And whether or not, like Alaric says, electric cars do not reduce fossil use, they increase it. And no, you cannot generate enough clean energy to provide for a car fleet. We understand that in developed countries. I'm playing devil's advocate as to why Dr. Mann cannot speak about the things we do, even though in his research and his collaboration with other scientists, he must understand. But he's also in the capitalist system. He's in the political, system. He is working with that, So I wouldn't even be surprised if there were some endowments or some kind of category of gift or charitable grant or unrestricted grant or restricted, whatever. I wouldn't be surprised if it's from an energy company, green energy. So there you have it, guys. There you have it.
If I can jump in.
You can jump in, and then Jennifer, I'd love to hear your thoughts as well, because I know. Well, Jennifer's going to go over that BBC article. Go ahead, Jim.
Absolutely.
I'm done.
I did a prior video, even before the last two, where I talked about zero emissions is not realistic, and one of the things I brought up was electric vehicles, and basically, there's some debate as to whether electric vehicles actually, the net result is less carbon into the atmosphere versus gasoline, diesel powered vehicle. Of course, that depends on the efficiency of the engines and so on and so forth. But the thing you have to keep in mind with electric vehicles is you have to plug them in to charge them up. And unless you are living in a home that's totally off the grid and you're powering your home yourself, be it wind energy or solar or geothermal, it's not zero emissions. You still have to. So you're getting your power from a power plant that's supplying electricity to your home. They're probably burning coal, diesel, gas, what have you. Mm-hmm. It's not zero emissions. Someone actually accused me of being a shill for the oil company after that video.
Really? We are absolutely not.
Wow.
And I basically said,
none of us are.
And I basically said, dude, the topic at hand was zero emissions. Electric vehicles are not zero emissions. But here's the other thing. What do electric cars run on? Batteries. What are the batteries made of? Lithium. You got to go mine the lithium. Mining is extremely intensive release of green, between all the heavy backhoes and heavy trucks and, that kind of stuff there. It's greenhouse gas release intensive. So even when you factor that in, you may sound nice, I drive an electric vehicle, but you have to look at the calculations. You have to calculate the total joules involved to get you to drive that, say, 100 miles or what have you.
Yeah. You might be right.
Anyway.
Okay, Jen. On to Jennifer.
Well, there was an article that came out in the BBC in 2009, November 2009. So this was 12 years ago. right?
Yeah.
And it was about Michael Mann, and he seemed very sincere. I don't know if he was already sort of a, quote, big star or not. It's a nice picture of him with his tree stump. He's counting tree rings and he's putting together climate models. But remember, Michael Mann is the guy who came out with the hockey stick. Yeah. By its very definition, the hockey stick is all about exponentiation. The hockey stick is a shape that goes like this. And it seems to me it's sort of like ironic, right? Because exponentiation doesn't go like this and then just stop, right? It just kind of keeps going until the source of what's making it exponential after God knows thousands of years or whatever stops, you know. But now Michael Mann's premise is that shortly after becoming carbon neutral, which, you know, that would be a really good trick. I mean, I'm not even going to go into that. Let's just pretend it's possible. But shortly after becoming carbon neutral, the climate would normalize within like a very short period of time, and we would all be saved, and it would all just be great. So how is it that a guy who really developed the whole understanding of the exponential nature of everything in climate, you know, anyone who looks at any graph at all, is suddenly a shill?
It's fear.
And is denying that exponentiation even exists. It's kind of like he's negating his earlier work. And I'd like to kind of get a response from Jim and see kind of what you think about that, because it's really kind of weird, right?
That was probably what I find most dismaying about what's going on with him recently. It's like, he's a physicist. He understands physics, you know, and you know, because let's say whether it's the atmosphere or the ocean, it's fluid dynamics, which is physics. I mean, he understands all that stuff, and for him to be suddenly saying these things, it's like, I'm totally befuddled. I really am. You know, I was trying in that video. I mean, I stated that I respect him. I was trying not to like diss him. I was trying to be respectful in my disagreement with him, but still, it's just like physics doesn't lie. I mean, you have the thermal inertia.
But when you make deals, right? When you make deals about the type of message, when you make deals and you're complicit about the type of message that you are going to put out, even if it doesn't really line up with what you know is true, you do all these little shenanigans, and all of a sudden you come out sounding perfectly, you know, normal, like everything's going to be okay. We just do this and this and this. And it's like, there's no urgency. There's no acknowledgement even of his earlier hockey stick theory. I never hear him talking about the hockey stick anymore.
Well, remember how controversial that was. Remember he was slammed by the fossil fuel industry, by the climate change deniers. He went through hell.
Just like Paul Ehrlich went through hell in 75 with the Population Time Bomb book. I mean, he really raked over the balls. You know, he's being correct. You know, it is befuddling to me. It is dismaying, and it does seem like he's forgotten what he's done before in the past. And quite honestly, it is not a realistic view when you look at the data, but you also look at the past. The key to understanding what's happening now and likely project into the future is to look at the past and understand what's happened in the past. And when you do that, with all the CO2 that's in the atmosphere now, it's not going to suddenly get sucked down in 2 decades. It's just, it took 2 centuries to put it in there.
Right. And even if it did, just the nature of the CO2 molecule in its heating journey to manifestation, right? It takes between 10 and 20 years. If all the CO2 emissions stopped suddenly like magic on Earth today, there would be many, many, many different feedbacks. But one thing we can count on is that CO2 molecule kind of blossoming into its heat ability to kind of manifest heat, and it takes like about 2 decades. That's just one thing, not to mention all the other things that would happen to make this thing still roll downhill, even if all CO2 stopped, and
But see,
not to
here's the
mention
thing,
the
though.
oceans.
If you look at the data, though, I mean, let's take the PETM. That's 53 million years ago or so. Look how long it took to draw down all that carbon. It took, almost 50 million years. So we have put right? We have put basically how many millions, hundreds of millions of years of carbon worth into the atmosphere in 2 centuries. You're not going to draw that down anytime soon. And when you throw in the methane, okay, don't forget, methane oxidizes into CO2. So
exactly.
Well, methane doesn't last as long. Well, it turns into CO2, which means the effects are still going to be there.
Yeah. Yeah. And also the nature of methane as it goes through the water column, if it happens to be like methane hydrate on the East Siberian Arctic shelf or something like that, as it's absorbed into that water column, a lot of it will come out because it's not a very deep water column there. But as the stuff that is absorbed gets absorbed, doesn't that also turn the water column right there a little bit more acidic? What's the effect of the methane being absorbed into the ocean? I think it's something, right?
It will. It's going to impact, what the phytoplanktons do, for example, which of course is the basis for productivity, and how much methane makes into the atmosphere, of course, is a function of the temperature. And so you have to look at the temperature of the water and the solubility curves of that. Now, if you have gas solubility increases with a decrease in water temperature, so colder water can absorb more gas into solution. But guess what? We're warming the Arctic water. And don't forget, on the Atlantic side, we have the intrusion of the North Atlantic intermediate water going into the Arctic Ocean, and that's warm water. It's warm and salty, but it's still warm water, so it is more dense, so it slides in underneath the surface water of the Arctic, but the heat is still going to move its way vertically, so you're getting the warming of the Arctic Ocean in that manner. Well, you warm the Arctic Ocean, you're going to decrease gas solubility, which means more of that methane will make it into the atmosphere. And by the way, it isn't just the ESAS. Norwegian researchers have documented methane leaking out of the Barents Sea floor.
Mm-hmm.
So there's stuff going on over there as well.
I saw a picture of somebody, and they weren't even taking it as looking at the methane. It was a picture of an Arctic body of water, and they said, "Oh, look at the methane bubbles," and they said, "How pretty this is." It was methane bubbles. But I do have one thing I wanted to mention. When today, Jennifer, you saw when Mike, Dr. Mann was on, and he said that the weather, and I guess this is a good way to maybe segue. He said, "Oh, well, this weather is normal weather pattern. It would be normal for the 50s or 60s. I didn't understand it because he writes that, that Earth's response to greenhouse gas induced warming might be more complex than natural warming. And he's almost saying that this was natural. So what is it?
Well, no, he was. I mean, I understand what you said, but basically, because the jet stream is so broken right now, and because it is dripping down like an actual melting ice cream cone over the continent of North America and parts of Siberia too, but really this one is more lopsided and it's over the continent of North America. Okay. That is directly bringing the Arctic air mass onto our heads. And what he was saying is, well, we were almost breaking temperatures. I mean, it got down even to freaking Mexico. That's cold, right? But because global warming is going on, we're not generally having like the cold winters that used to be had like at the turn of the century or something like that, because it's actually warmed that much. But he was saying that this, would have been a normal winter maybe in the 1800s or 1850s. Okay, fair enough. But thing is, it
wasn't
got all
understanding.
mixed up with gobbledygook. And what needs to be understood here is, why is this happening? And the reason that this is happening is because the jet stream has gotten intruded. Exactly, Sandy. And we basically, the whole thing, because it is a delta between the cold air and the warm air, and the Arctic is warming faster. That's Arctic amplification. And as the Arctic warms faster, the difference between the temperate regions and the Arctic regions decreases. That's the delta, and it starts to move slower, and it starts to break down, and it starts to get wavy, and all of these things, right? And that's what we see happening, and that is why it's falling onto our heads. And this is an Arctic air mass. This is a temporary situation, maybe not in terms of like right now, but like in terms of 100 years or something. I don't think we're going to keep having these massive Arctic amplifications that are falling on our head. This is the death of the Arctic, guys. This is the death of the Arctic. The Arctic is in its death throes. And as it's dying, it's breaking parts of itself off and throwing it down. And that's what it is. This is a hunk of the Arctic that's fallen on our heads. If it's down here, it's not up here, up there. And if it's down here, it's probably all just going to get hot, and it's not going to go back up there anyway. This is the Arctic just throwing off parts of itself as it's getting destroyed. And I'd like to go to that.
Yeah, I did a recent video saying that the Arctic is in a death spiral.
Yeah,
and, exactly. It's in a death spiral.
As to what's going, and one of the things that
thanks, Rich Diana. That's hysterical.
In this spiral is the sea ice. The sea ice is the big driver, right? In my opinion, because without the ice, you don't have the albedo. So you're having more and more absorption of the heat. So I mentioned earlier the Arctic Ocean is absorbing the heat. You have the influx of the NAIW. You also have influx through the Bering Strait from the Pacific side, which is bringing in warmer water that helps keep the ice from forming. So you have all these factors contributing to the loss of the sea ice, which then creates this less of a temperature grade, which translates into less of a pressure grade. And then when you so you start getting the change in the jet stream from a strong zonal to a weak meridional flow. When you also look at what is another contributing factor to the current situation, as far as the Texas goes, is that the Arctic oscillation has some of the highest negative values ever calculated. And generally speaking, Sandy showed that the graphic earlier. With the vortex, when the Arctic oscillation is in a positive mode, you get the zonal flow, what you see on the left side of the graphic. When it's in the negative, you get the meridional flow of the jet stream, which is what you see on the right side. The more negative, the more it dips down. So that's
Jim, that's a controversial picture as well, that graphic, that there is controversy about the actual whether or not this is agreed on science. There are scientists that still don't agree that this is happening because of that. I have it, but I didn't pull it up.
The scientists who don't agree study the tropics. They don't study the polar
exactly.
regions.
That's what I read. Oh, Jim.
Yeah. So it's like, well, us folks here look at the polar, we kind of play with it every day. So I think I'm on that issue. I'm going to kind of go with the polar guys. But
okay, you go with the polar guys. Yeah.
But here's the other interesting thing.
Go with the polar.
With the Arctic oscillation,
polar guys win.
With the Arctic oscillation, you have also the North Atlantic oscillation. Generally, the two track as far as what sign the index is on. The North Atlantic oscillation is on the negative side, which creates a wavy jet stream that will affect the weather over in Scandinavia and Europe. As to why it's lopsided, so that we don't see that dip down on the Eurasian side, that's due to the Arctic dipole and how it can and where this high and low pressure systems are sitting. There was the article we were looking at before we went on air. We had all the the highs and the warm and the cool spots on the atmosphere. If you look at that graphic, you can see where I think it was in the
We're
one.
going to pull
If you look at
that
that
up.
graphic, you can see where the high pressure system is sitting over on the Eurasian side, if I remember it correctly.
Okay, let's pull it up
Yeah,
and see.
let's go ahead and bring that graphic up from the
The
Washington
yeah.
Post. This article that came out is really, really fabulous. Link will be in the show notes. And it basically talks about this atmospheric setup in terms of the polar vortex. And it's got a lot of good graphs, which Sandy is probably showing. So you can kind of see how it settled into the deep Midwest there and kind of pushed all the way down. But there's one in particular, Sandy, and I think you made a file of it that I wanted to talk about.
I don't know if it was successful, but I'm going to bring it up.
Okay, yeah, just go down there. That's it. Yeah. So this is a higher air anomaly index, and it really depicts the jet stream and the different temperatures. So red is warmer than normal, blue is colder than normal. So you can see how, if you see where that blister of red right across the screen, that is actually cutting through from Western Siberia. You see how Alaska's ending up in the Aleutian Islands, and then there's Siberia right there up in the, I guess, more upper left, right? And that the hot air, high pressure, like is high pressure and hot air is pushing right through the Arctic, and it's actually disrupting the jet stream and causing the jet stream almost to like break parts of itself off. And so you can see all that cold air pushed to a couple of places. One of the places is the United States. One of the places is just south of Greenland. That's actually colder than normal, interestingly enough. There's a little bit colder than normal in Siberia. And right off the Aleutian Islands in Alaska, it's colder than normal there too. But this is in direct response to this disturbance of the jet stream due to the Arctic amplification. And if you could clarify any of what I said, Jim, I'd appreciate it. If I missed any salient points there. It's a real good article.
That's a good summation to illustrate the main point here of how the system has been extremely disrupted. And the other thing is, like, when human civilization arose, the climate was pretty stable. Well, we've now done enough to muck up the works that we have taken the system and made it unstable. And in trying to in the Earth system trying to basically reset itself because of the continual perturbations, it's not going to find its new equilibrium state. And so you're going to get crazy events like what's happening in Texas.
Yeah,
and this is worldwide.
Not ready for this stuff. Oh no, they are not.
This is worldwide, as with all the disruptions to the system that you get, like you had it in Colorado. It was 92 one day, the next day it's like it's snowing and quite a bit of it.
Yeah.
I mean, so you're going to get these crazy swings because the system's been perturbed.
Freaky. Remember, guys, if you have questions out there, you have to put a Q, because we'll be doing a question and answer in a few minutes. So
I heard John Delancey is not available though.
Stop. But so put a Q. We've got a lot of people with us. So Jen, do you want to go on with any of this article, or do we want to move on to the carbon brief, the older the last year's article about the controversy about this? All right.
I want to move on to the carbon brief because time is short. And also this is just a good overview about how Arctic warming is linked to the polar vortex and other extreme weather, because this is just what we were talking about. And and the main point here to take away, we've got Arctic amplification, and what that means is that the Arctic is warming more than twice as quickly as the global surface average. And this is known as Arctic amplification. And this is stemming from the rapid loss of sea ice cover in the region. So we all know about albedo. As the Arctic sea ice diminishes, it's not as reflective in its blue ocean, and it's going to absorb a lot more heat, and that's a feedback, and that adds to Arctic amplification. And over time, we can see that the Arctic sea ice has been going down exponentially to the point where we don't think that there's going to be ice in the Arctic during summer, after probably the next couple of years. I'm not sure on the estimate. It always lasts a little bit longer than you think it's going to, thank God, which always surprises me because I always think, oh, well, our goose is cooked now, but, kind of stumbles along. But nonetheless, the Arctic sea ice is going away, and this is going to have a huge, giant effect on this polar vortex disturbance. And the polar vortex is going to continue to be chaotic and dissolve and cast off parts of itself and cause extreme weather events. And it's all part of the dying of the Arctic. And that's what we're seeing right now. And the Washington Post article and the Carbon Brief article are both really, really good. Recommended to read them. The Carbon Brief article has an incredible graph from Climate Reanalyzer, and it's basically a temperature anomaly graphic. And I don't know if you see that, Sandy, but it's got extent.
I'm going to bring it down. This is the Climate Reanalyzer.
There you go.
Yep, there you go.
That one.
And this was from 2019, but that's not too bad.
It doesn't matter because the principle is the same. The trend is the same. The science is the same. And the takeaway is there are deep anomalies, which are mostly registered in the Arctic and a couple of other regions, in the hot side, and then deep anomalies in the cold side as the Arctic casts itself off. So that's what you can see time after time after time. I personally first became aware of the splitting of the polar vortex, I think about 2014 was the first time I really kind of woke up to it, and I really have been watching it ever since. So like 7 years now. I don't know, Jim, when you first became aware of the splitting of the polar vortex, did it start splitting prior to 2014?
Yeah. I mean, obviously that isn't my area of research, but I work with people. They were looking at that. In fact, there was a hypothesis that was being formulated towards the end of the 1990s that climate change is going to affect the jet stream. So this has been an area of active research for over 20 years. In fact, it was part of that research, along with the stuff I was doing with the sea ice, that led to the discovery of the Arctic dipole, of course, which does affect indirectly what goes on with the jet stream. So the jet stream, this hypothesis has been out there for a while. This has been an area of active research for at least 20 or so years. So another thing to keep in mind is, with the sea ice, okay, we've lost just about almost all of the multi-year ice, which greatly impacts the albedo because now more of the energy is being absorbed. Even with the 1 year ice that forms, that's still pretty translucent. Okay, now if you have snowfall that covers it, okay, fine, the snow is the albedo, but the ice itself is translucent. So even when you have 1 year old ice, if there's no snow cover on it, sunlight energy, the right time of the year, will still penetrate through the ice, which of course can add heat to the ocean. So you got direct absorption of solar energy from the atmosphere, warming the surface waters of the Arctic Ocean. You got the infiltration of warm water from the Atlantic side, the North Atlantic Intermediate water. You've got water coming in from the Pacific side through the Bering Strait. All these and that's of course warmer water. All these factors are keeping the Arctic Ocean warmer than usual and help to not form the ice or help to melt the ice sooner. So you have all this latent heat energy. You have to give that off before the ice can even reform. And that's happening later and later in the year. And then you have the infiltration of the water from the Pacific and the North side, that keeps the water warmer. So any ice that does form melts the ice sooner. So you're having less of a window as far as for when the ice is there. As far as the BOEs go, the modeling that I'm looking at is saying 2022 to 2024 might be the first BOE where you have a totally ice-free Arctic Ocean for at least a couple of months.
Long?
Now, it used to be, the definition used to be, well, if you have less than a million square kilometers, that's ice-free. Well, you still got some ice, but whatever. Now it's like zero ice anywhere. You can sail up to the North Pole, for that matter, without an icebreaker.
That's amazing.
But when you project out of the BOE, the models are now indicating that by the mid-2030s at some point, if things continue as they are, the Arctic Ocean is going to be ice-free year-round. There will be no ice, period. And when that happens, it's game over. I'm sorry, it just is.
And you can't really refreeze it either. And the Arctic Ocean is going to be absorbing all that sunshine in the summertime. 23 hours a day at its peak, and that very, very shallow lap of sea, so rich in methane hydrate, right? It's going to start just coming out exponentially. And I don't know why people say it's not. That is very puzzling to me. I mean, it exists. It's going to warm up. So if it warms up and it exists, then what? Right?
Well,
it's I mean, and don't forget, I mean, we've discussed this before, but you have ice edge productivity. You have productivity under the ice where the ice is translucent. Okay, sun energy can activate algae, for example. And you get a little productivity. You're going to lose all of that, and so then the pelagic phytoplanktons will take over. But the pelagic phytoplanktons can't do their thing until the sun is at a high enough angle to activate the electron transport chain system within the chlorophylls, the chloroplasts, so that they can start the photosynthesis process. So the net result is going to be a decrease in productivity for the food web up there in the Arctic Ocean, which of course is not good.
No.
And then you couple that with what I've been talking about, the stabilizing of the oceans.
Yeah, exactly. That's the stabilizing is a terrible thing.
Everything is hitting all at once.
Yeah.
Well, speaking of
it's all going to hit all at once.
I would like to go on to this article that I have that I wanted to ask you guys about, because we're talking about Texas, we're talking about we're never talking about other places, and heavy snowfall gales as winter storm hits the Middle East, and snow blanketed Syria, Lebanon, Jordan, and Israel, blocking roads, disrupting traffic. They had the parts of the capital of Damascus, which is witnessing the winter's first snowfall. And Jennifer, you had mentioned Greece in the beginning of the show, so I just thought we could just go over this and say it's happening in other places, and they weren't expecting it. But my questions, of course, are, I don't remember hearing about snow a lot in these areas in the Middle East, and this is horrible. 3 million displaced people live in northwestern Syria, mostly in tents and temporary shelters. It's absolutely horrible, and I want to know, basically, guys, is this a typical for that area to get this kind of snow?
It certainly is not. And I don't think that Greece, had gotten anything like that in like 140 years or something really crazy. So that's why I think Michael Mann was whitewashing it. And I understand with what you're saying, Sandy.
Yeah.
He was oversimplifying it because there are extreme weather outbreaks taking place all over the world. This thing went all the way down to Galveston, Texas, which is basically, right down there in the Gulf of Mexico. And they were unprepared for any of this. And, well, who knows? That's going to be like a whole nother topic, which we don't have time to get into. But let's just keep it to the weather itself. In the Middle East, it doesn't get this kind of weather. So this is abnormal. This is like extreme abrupt climate change due to the shattering of the polar vortex. So you have to see it for what it is. It's not like that mysterious. It's like you break something, that something comes and falls on your head, and it happens to be Arctic air. But you look at it, it's a dripping ice cream cone. Where does the ice cream cone drip? It dripped over in the Middle East. It dripped in Texas. It dripped a little bit in Siberia as well. So you're going to get these extreme weather events. And at the same time, you're going to get heating that is just getting even worse. So there you go. We're all messed up. Nowhere to go. Sorry.
Yeah, tell the city.
And just imagine how the Palestinians are suffering.
Oh, they are. They are. They've got to be. It's awful. It really is. Israel just said that they're just giving them vaccines. I mean, they're treated horribly.
It's
horribly. But this is all over the world.
It's just crazy.
It's not just there.
It's just.
Yeah, I know.
Oop, there we go.
Let me see if I have any more funnies.
It's
just because we're so serious. Oh, here.
I know.
There's the other one. The Republican lie. The wind turbines break down, but look at Russia, Denmark, Norway, and Antarctica. That was the other thing that was going on all over.
And and someone actually said, "Well, they don't have any ice there, so that's why they don't break down." It's like, shut up.
Yeah, shut up.
It was
they put a coating on the turbine to protect them from freezing up. The ones in Texas did not have the coating.
Right.
I do like the graphic of Ted Cruz.
Yeah, that was a good one. But we do have to take questions tonight, guys. I promised questions tonight. I really did. And some people have questions, and I have to go back to Mike Petty had a question. Let's start with I can't find it now. See, that's why I wanted the cue in front of it. I think he had a cue, and I'm looking for the cue. Bear with me, guys, because it's your night too, and I really wanted to put this one up. Okay, here we go. Why, just like we were talking about, why is Texas blaming the lack of power on windmills? Do they all have 3 thumbs?
Absolutely. I think that the right wing and the Republican Party took this and as an opportunity to go against like windmills.
Yeah. Yeah, I know. Here's the question. Mike, what about the Porter Ranch, California methane leak in 2015? This event sped up global warming, in my humble opinion. People think he says, people think it's a joke. I think Texans should crack open a science book. Mike's funny. I see him in a different chat on Nicole Sandler's show.
I want to know, I just want to know one thing. Is that a picture of Mickey Mantle?
It looks like, is it, Mike? It could be. Michael answer. But what about
like a rookie card of Mickey Mantle?
Maybe. What about these methane leaks in these different places? That are they of any substance in this conversation? As opposed to the methane that's hidden in the permafrost.
There are a lot of well caps, a lot of methane wells, gas wells, whatever, that have been capped off. They're still leaking. It's the methane is finding a way to leak out of these well caps. So yes, that is a contributor of the methane levels.
And you're
yeah, I think so. And it depends on how much is coming out. But in that Porter Ranch episode, it was a huge amount, and it was gushing out for months and months. And clearly, you think, well, just like one pipeline leaking methane is not going to have any effect. Methane has the heating potential of like something like 120 times when it first comes out, molecule for molecule, from carbon dioxide. It is going to have an effect, and it has a localized immediate heating effect. So that could mean that the localized air around there, because methane is immediate, it doesn't have like needing 10 years or 20 years to heat up like carbon dioxide. It just, you shine the sun on that, it's nice and bright and hot already,
and
so
bubbly.
It provides and bubbly. We'll take methane with that, please.
Oh my God.
Yeah.
Well, I have another question from John Schmidt. Hi, John. Would you prefer high or low altitude dimming of the Arctic? I don't understand it, so somebody else has to. Is it a thing?
What's the reference to? I'm
I
not
don't
quite
know.
following.
Well, I didn't
Jen,
see.
you have an idea?
I
I
don't.
am not entirely sure. All I was
No, I'm
thinking about
sorry,
is
John.
maybe marine cloud brightening, and that's the only reference I could kind of tie it to. And whether you inadvertently dim the clouds that you're trying to brighten, through particulation. I mean, I'm just kind of going off on my own right here. I don't even know what the. Sorry,
All
I
right.
can't be helped.
Well, David McHugh says mitigation. Can we use the time gained to gain new initiations? Please look at Project Mirror Reflection. Great talk, though, guys. And you know what? Things I'll answer a little slowly. Go for it. They're going to go for it. Scientists are going to go for it. Technology is never going to stop happening. And that's my answer. So I say go for it, no matter, who am I?
I actually saw an interview. I forget the gentleman's name on with Guy McPherson talking about the Mir project, and it's interesting. It's one of those geoengineering ideas that does not involve active procedural matters. Not like let's dump aluminum sulfate into the
Yeah, forever.
atmosphere, that, or
Horrible
throw
thing.
iron into the ocean, or that kind of stuff. This is place mirrors wherever to reflect sun energy back. And in listening to the discussion, about 93,000 questions popped into my head about,
Really? What
you
did you
know,
think of it?
about what's going
Is
on.
it a good idea? Is it a viable idea? What do you think of it?
Well,
Seems crazy, but that's me.
as we like to say, there's theory and then there's reality. On paper, it sounds decent. I am skeptical, dubious, whatever word you want to use, about the practicality. For example, they're talking about placing some of these mirrors in the water. Well, when light goes through the water, there's attenuation going on. So a lot of that energy is scattered. So you would have to place those mirrors in very shallow locations. And even so, it comes in. Is the energy going to reflect totally through the water column again, however deep it is? And don't forget, sunlight energy comes in on the short wave end of the spectrum and reflects back out on the long wave end of the spectrum. So there's going to be an energy shift, if you will, of what goes on. So I have a lot of questions, and I'm actually going to try and have a meeting with this gentleman who's in I think Ireland or something like that, to have a discussion, and where we can discuss. He's working on it, and I want to pick his brain, and
All right.
maybe he can answer some of the questions that I have. But it's
All
an
right.
interesting idea. I don't want to be dismissive of it, but as I always say with geoengineering schemes, you got to be careful because there are
Don't
always
like them.
unknown parameters, unknown, unanticipated interactions yielding unintended results and
Yeah.
consequences. So I always put that caveat out there
Yeah.
just as a cautionary note. But as I said,
Yeah.
I don't want to be dismissive of this.
All right.
Let's
Well, listen.
see. Let's see where it
Let's
goes.
do this one. Rich Diana, because this might give us that little 5 minutes of Gates. Rich Gates has 100 million competition started for creating carbon capture and removal technologies. Well, guys, by the way, I have something about Gates, but we're not going to go through it. We can't. We don't have time. But it's Michael Mann does not like Bill Gates. And there is an article here. No, he doesn't at all. And there's an article from the New Statements, The Rise of the Climate Dude. And it's got Bill Gates. But what I wanted to read, and since Rich, you brought it up, I want to say what they said. Let's see. Bill Gates has set out to solve a problem like climate change rather than flighty moonbeams. He's putting his faith in moonshot technologies, which he believes will create problems. But I want to go down and find where the guy says, all right, how to avoid a climate disaster. That's his book, right? But they then go to Michael Mann's book, which is the new one,
Right.
and that they say Mann is the genuine article. He started the field in the 90s.
Yeah.
And Gates is a classic example of first time climate dude believes, man, this phenomenon is the tendency for members of a particular privileged demographic, primarily middle-aged, white, and almost exclusively white men. Jim, you're not in that right now, okay? To think that they can just
No, I'm just old.
Stop. To think they can just swoop in and solve the great problems that others have spent decades unable to crack. The result is a mess consisting of fatally bad takes and misguided framing couched in deeply condescending mansplaining. So Mann argues that science, not unproven technology, should be the guiding principle. Yay! Electrification, energy efficient, existing renewables, solar, wind, geothermal, hydroelectric, yada yada. But he says Gates says geoengineering is cutting edge, break glass in case of emergency stuff. And let's see. And what did Mann say? It fired doom mongering, though. It fires up man. He says in a book, he heads an army that discounts the prospect of failure. The climate crisis is real, but it is not unsolvable, he says. And it's not too late to act. The opposition is no longer the climate deniers of yesteryear, but a more insidious group, doomsayers and defeatists who push climate doom porn and the idea that climate change is just too big of a problem for us to solve. They peddle the other D's: disinformation, deceit, divisiveness, deflection, and delay. And I will say one thing: we don't do any of that on this channel. And we don't do any of that. And that, but he really, Michael Mann just can't stand Gates. So thanks for Rich Diana for getting me off on that one. I do actually have a screenshot from the book. And today, fossil fuel interests in the climate and activists working on their behalf, and I know nobody like that, are seeking to block policies aimed at regulating carbon emissions by employing a crying Indian-like deflection campaign, whatever that means. It is instructive to know What? Go ahead. I'll just want to finish it. What?
Okay, go finish it.
Okay, some of the striking, I know we get excited, the parallels between the current campaign and deflection campaigns in the past. The silly contention by right-wing figures like that climate activists want to take away your burgers, for example, sounds a lot like the NRA's admonition that gun law reform advocates want to take away your guns. Both reflect an attempt to prey upon fears of big government and limitations on liberty that are prevalent among political conservatives. And go for it, Jim.
The crying Indian is a reference to commercials that were appearing in the 1970s
I remember
about environmental degradation.
Sure.
And of course, the actor playing,
wasn't an
Indian.
The
actor playing that, he was Sicilian.
He was not native.
Yeah, he was Sicilian.
Yeah, you remember that, Jen. I mean, we were all, at a certain age, we were all marked with that. We all were. So it's just interesting. This whole, and that's why I put in the show notes that the controversy, because it's not, we're not
But see, that's
fighting.
That's why I had to do that video.
No, we're not divisive.
Do that video because Michael Mann is dismissing thermal inertia. I mean, you just, as a famous engineer once said, you cannot change the laws of physics, Captain. It's just,
Jen,
it comes down to that.
Well, it's absolutely true. You can't dismiss the laws of physics. And that is what I see Michael Mann doing. And that's why we keep coming back to him again and again, because he actually has changed. I think he started out as, a sincere guy, and it's an opportunity to play this role. But in order to play this role, he has to say he will be complicit, and he has to agree to the rules and very strict parameters. And it's making his message come out as very insincere and very kind of, in a strange sort of energy. You know what I mean,
not
Jim?
to a lot of people on Twitter and in the communities. I mean,
I would agree with that, Jennifer.
I would too, Jennifer, but it's not in the communities out there.
Yeah.
People love Dr. Mann, and there's no reason
good.
not to, because that in this administration, they're going to push the electric vehicles, and that's why Granholm is in the position, because she's Detroit. So it's not I'm not saying this to criticize. I'm just stating a fact. This is what's happening. I believe that he is definitely a very big part of that. So, all right, let's move on. Billy Joe. Billy Joe's Mo. I have a question about the ossification of the ocean and the dead zones growing every day, not to mention the heat and oscillation of the oceans becoming an emitter rather than a sink. And I know you're an oceanographer, Jim, but I'm going to give Jennifer a stamp first.
Well, absolutely. And as the oceans become more stratified and, quote, stable, they don't mix and they heat even faster. And the top layers are going to be the hottest, and they're going to be absorbing, and the most acidic, because they're going to be absorbing all the carbon dioxide. So the ocean, we're 70, what is it, Jim? 77% ocean on this planet or something like that. It affects life on Earth.
You said, remember, Jen, when you said we should be called ocean and not Earth?
Yeah. Oceanus.
Yeah. She just said ocean. We're ocean, not Earth.
Yeah, that's right.
Ocean is actually, I think, is a Greek
word. But I think
like
that I'd really like to hear Jim's take on this as well, because he's an oceanographer, and if anyone knows the ocean and what's happening in the Arctic in the ocean, it's Jim. So,
Well, obviously, it's basically what Jennifer just said. I mean, the oceans, because of the thermohaline circulation, which is really nothing more than density currents. Look, that's what thermohaline circulation is about. Density current. You have dense water at the surface, it's more dense, so it's going to sink through the water column. That sequesters CO2 and heat, takes it from shallow waters, brings it down to depth. That also mixes the water column. You have, kind of back up here a little bit. If you go into the tropics pretty much has almost a near permanent thermocline in the upper layers of the water, because the sun's always beating down on there. So there's not much productivity going on in the tropics, because yes, they have stratification, but they have no mixing to bring in nutrients so the phytos can do their thing. When you get to temperate latitude, you get what's called a seasonal pycnocline, thermocline, depending, but a sharp gradient, where you have sufficient heating, you get a stratification that's temporary, after a mixing event, where now you have nutrients and the phytoplanktons locked into the photic zone. They're in the photic zone. They can do their thing. You get a nice little food web. Come autumn, winter time, the ocean, that seasonal thermocline breaks down. You get mixing. We're now in danger of having permanent pycnoclines that are shallow. There's a permanent pycnocline in the ocean about 1,000 to 2,000 meters down, depending where you are on the planet. It's shallower as you get to higher latitudes. But we're talking about surface pycnoclines about a couple hundred meters. If you have that permanent, if that sets up as a permanent pycnocline, you're not going to have any mixing at all. And once the phytos run out of nutrients, then what? And I used to be of the opinion, I said this in my videos, that, and the data shows this, when you shut down or slow down AMOC and the colloquial called the conveyor belt, it tips the planet into a cooler regime, if not an ice age. There's now so much latent heat energy down to 2,000 meters that even if the thermohaline circulation shuts down, you still have all that latent heat energy that's just going to eventually make its way back out into the atmosphere. We're talking, something like 2 times 10 to the 23 joules of energy worth. And that's how much the oceans have absorbed of our burning of fossil fuel. Most of the fossil fuels that humans have burned have gone into the ocean, not the atmosphere. People need to understand that. But so what happens now? Up the ocean, gas, we talked about this earlier this evening, gas solubility decreases with an increase in water temperature. Eventually, you're going to reach saturation where it can't absorb any more CO2, further warming that CO2 and the oxygen is going to be blasting back into the atmosphere. Well, so you increase the CO2 levels in the atmosphere, therefore you're going to have increasing the warming, right? You're losing the oxygen levels. Organisms that have gills are going to start dying, and we're seeing some research showing this. Larger fish are dying because of decreasing oxygen. So you have that, and another thing that's going on is what's called the calcite compensation depth, also known as the lysocline. Basically, when you pull CO2 from the surface water to depth, you're decreasing the acidity in the surface waters, but increasing the acidity at depth. When now, as Jennifer just pointed out, if there's stratification and no mixing, the acidification stays in the upper layers. Well, the calcite compensation depth, in a quick, like 20-second summary, is below that depth, calcite, which is a form of calcium carbonate, stays in solution. Above that depth, it can precipitate out. Organisms that use calcite to make their shells are able to absorb the calcite from the water to make their shells. Well, we're finding that this calcite compensation depth, the lysocline, is getting shallower and shallower, meaning that organisms are having more and more difficulties making their shells, making their tests, which is exposing them to mortality,
Jennifer, you've talked
to increase
about that
mortality. So we have that going on as well. That's another thing you don't see being talked about. But so you have all these things happening, and don't forget, phytoplankton supply 55 to 80% of atmospheric oxygen. You start losing the phytos, and atmospheric oxygen levels are being shown to be decreasing. The decreasing, I attribute to two major things: burning of fossil fuels, fossil fuel plus oxygen, right, gives you CO2, and the decreased output from phytoplanktons. It's very serious.
It is very serious. She said that she was reading about oceanographers placing concrete shapes into the oceans to create more phytoplankton. Did you read about that? Well, Kim, send me the link if you find it.
That's a new one to me.
Yeah. All right, we're going to go back. I'm trying to. I want to get everybody's questions.
It has to be near shore areas, because once you get out of the littoral zone.
Yeah. All right. We're it doesn't matter if we go over, because everybody's got questions. Now, Patrick has his project, but here's his question. Theoretically speaking, what would happen to global weather if you parked a Cat 5 hurricane over the Gulf Stream for 1 year and it upwelled 5 degrees Fahrenheit cooler water over that entire time frame? And I think this might have to do with his Otec project. And I don't know if either one of you have seen the video I did with him. I did an interview with him, and he's so. Is there an answer to this, or is this kind of like?
I have no response to that.
Is that the project with the pumps?
It's the ocean tunnels.
The
ocean. Yeah.
I'll share that with you, Jim. I didn't know. I just thought I would put that up. Otec. And Rick has one too. Otec, Ocean Thermal Energy Conversion, and he's got an article also. Rick, could you send it to me? Please send it to me. All right, other questions. Okay, here, Scott Murdo. Scott has a request for Jim to do an explainer video on quadratic functions and which Earth system variables are most at risk to be heading that way. TIA if you can, Jim. All right.
It's a little more complicated than quadratic functions. And actually, finding solutions to higher polynomial equations is not as simple as it may sound.
Okay. All right, let's see here. Jeremy has a question, theoretically speaking, and thank you for following the directions. Oh wait,
This is Patrick's question again.
No, I have to find the other one. Sorry. Where was it? Oh darn it. Oh, I lost it. Okay, let's see. Oh, Scott said, "Whoa," to your question. Hi, Val. Yes, we all know that Rush Limbaugh bit the dust today. Absolutely, we
Oh,
all
did he?
know. Yes,
Well
he
done.
did. Yeah, he's well done.
Rest in peace.
Jennifer. Well done.
I know, it's horrible. I'm
I'm
like callous. I'm
he's horrible. What a horrible person. Oh my God.
I think it's time to cue up a certain song by Queen.
Another one bites the dust. Another one bites the dust. And then there was
you should have that sound bite, Sandy, and be able to play it on command.
Yeah, as long as I don't get a copyright, because
Oh, that's
I might
right.
sing it and do it myself. I can record it and go. Another one rides the bus.
Yeah, we'll whip out my bass guitar and just go.
Yeah, let's do something together, Jim. I sing, you play. Okay, we could do this. We could do that. Yeah, we can make our own things and we won't get copyright bullshit, even though I'm not monetized. But okay, let's see. Oh, Jeremy, I'm actually like to hear more about the oceans. Cool, go to Jim's channel. He's got a whole channel, Science Talk with Jim Massa. It's a wonderful channel, and he's part of our team now. And he comes here, but you can go there for all these really in-depth videos. Now, are you familiar with Sky Punch? John, you ask weird questions, so we don't know.
I don't know what Sky Punch is.
Okay, well, I guess the answer is no. Well,
it sounds familiar, but I'm not.
Else?
My memory banks are not pulling it up right now.
Jeremy said, "Thank you for helping us understand the spatial dynamics of the ocean. I think it's hard for most of us to grasp how different the ocean is from the Earth's surface and the atmosphere." Well, thank you, Jeremy.
Well, what's the saying that we know more about space than we do about the oceans? Mm-hmm. Which is true.
And it's
the Earth and atmosphere are a coupled system. They're both considered to be fluid. I didn't say liquids; I said fluids. And so the equations of fluid dynamics apply to both. But when you consider all the not just horizontal but vertical movement in the ocean, latent heat, all the other processes, chemical processes, a lot of similarities with the atmosphere, but the oceans are really a big driver of climate, as we're now seeing with what's going on in the Arctic, and more specifically, the loss of sea ice in the Arctic Ocean and the heating of the Arctic Ocean. So we're seeing that because, don't forget, water has a higher specific heat, so it takes a little longer to warm up, but it also hangs onto that heat for longer than does the atmosphere. So there's going to be a lingering effects for millennia from what's going on right now.
Wow. All right, let's see. Well, actually, Patrick wanted to answer, but you know what? I think I'm going to send the video that I did with you to Jim, so Jim can digest everything, and perhaps Jim, maybe he'll do a show on you or whatever. I'll just hook you guys up. There's not enough time, I think, to answer that. But and of course, Val thinks that the only thing that he can see that can solve this massive complex problem is a super advanced super AI, because then that takes it away from humans having to do it, right? Val has a whole thing on this too. We have an amazing following, Jim. And a lot of our followers have now gone to you because you have been on Black Bear and our channel, which is great. And I'm glad that I was able to do that because, and Jennifer, I'm just the one that I like to share people. I don't hate people. I find the people I love and I bring them on and it's great. So let's see. All right, guys. Jen, would you like to talk about this article, the resilience article, and just say everybody should read it? We won't talk about it, but
yeah, absolutely.
Right. I mean, we're over time anyway. What's the difference? We have this fabulous article you guys should really read.
Yeah. So there is a great article that will be in the show notes, and you all can read it. It's from resilience.org. And the title of the article, Worried About Earth's Future? Well, the outlook is worse than even scientists can grasp, has 3 authors, one of them being Paul Ehrlich. And it is comprehensive and tries to take in everything to get to come to grips with the problem by looking at the richness of the different things coming into this, and the ignorance of human behavior and optimism bias, and that can make your message different as we don't know. And it talks about some very interesting facts, like, we've had the vegetation biomass on Earth in the last 11,000 years. Think of that, guys. Since the end of the last ice age, 11,000 years ago, the amount of vegetation on planet Earth is half of what it used to be. It's just stunning. So I think we all owe it to ourselves to become knowledgeable about this topic, because we live in such profound time on Earth right now. 6th grade extinction.
Yeah, it's a good article. So that's why. So everybody, it'll be in the.
I'm know that basically has measured that there's more biomass from human technology than organismal biomass. In other words, when you look at the buildings and the roads and the concrete and the asphalt and the jungle, etc., jungle, the concrete, asphalt, steel jungle, there's more biomass from that, more weight than the biomass of organisms on the planet now. It's crazy. Talk about terraforming.
Wow.
Yeah,
Well,
it's
hello,
absolutely.
In this case, it should be
South.
terror. Terror forming.
We have Going South with us.
Mind-blowing.
Human Love and Solidarity. Mike Walter, a bit optimistic, but better than most. Mike had a question way in the back. I mean, way back, and I don't even know where it is. Wait, maybe I could just take it. I mean, it's a good show. We're enjoying this. I'm trying to find it, and that's the problem. Mike, are there any, here it was good. Are there any ongoing modeling efforts to predict how and when these changes are going to affect global crop yields?
The answer is yes, and I can give you a brief synopsis of what these studies are finding. I've actually discussed this over at my place there. Crop yields are declining worldwide. Let's start with that. Whatever crops are being harvested, the nutritional value is declining as well. So it's a double whammy. And as you add more people to the planet, you're putting more pressure on the land, because you need land to house people as well as land to produce food. And we're losing more and more usable land for farming because of climate change. So this is going to lead to mass starvation. It really is. Another, going back to the oceans there, if the phytos start dying off, well, the fish that 2 to 3 billion people on the planet rely on, they're not going to be there. Another factor contributing to mass starvation. So yes, we are losing plants. And the plants that are being harvested are less nutritional. And with sea level rise, we're now starting to see the influx of seawater into aquifers that were freshwater, now becoming brackish, filled with brine, which is killing those crops. So that's another thing that's going on.
A lot going on. My God. Well, I think I'm going to end with Val. Neanderthals lasted longer on this earth than us before they went extinct, over 400,000 years, compared to about 250,000 compared to Homo sapiens. And yeah, give us a thumbs up, everybody. Thumbs up. Yay, we want thumbs up.
Well, Neanderthals did have larger cranial.
Yeah.
By the way, there was a Neanderthal flute that was found made out of a femur of a cave bear. It was 50,000 years old, and it
Wow,
was
that's cool.
intact enough that they
Oh
were
my
able to
God.
take a CAT scan of it and basically reform it, and they made an exact duplicate, and they played it in the same Neanderthal cave where it was found, and it's 50,000 years old. I mean, that
That's
just
pretty
sends
wild.
chills up my spine, right?
That's
It's
mind
pretty
blowing.
cool. Yeah, it's really
Wow.
mind-blowing. So
All right.
Neanderthals are always worth another look. I think they're very interesting.
Oh,
Well, we do
Susan,
have Neanderthal genes.
Oh, really? What brand is
Seriously.
that? Where can I get them? All right. I guess. and Rich said, Jennifer,
I don't know. I
that's
have
so
to do
cool.
genomic sequencing.
Okay, I'm ready. Oh, I think that don't all those those DNA tests, don't they all come back with some kind of Neanderthal in them? That's what I heard anyway. All right. So I think we have done a good show. I love you both. Thank you so much, Jennifer and Jim and everybody that that's been with us, John and Rich and Susan and Jeremy, all of you. Thank you for coming. I'm going to give both of you the last little statement, and then we're going to be saying goodbye. Who would like to go first?
I always say ladies first, so Jennifer.
Oh, well, all right. I'll see if I can pull something out. I mean, it is just a time of contrast. You know, on the one hand, some people don't even believe in climate change. On the other hand, climate change is accelerating and causing huge, abrupt climate change events, causing hunks of the Arctic to fall off and come onto our heads. And still we don't get it. How obtuse are we as a species? I think this is time for the human species to take stock of this situation and really start to understand what's going on around them rather than what they want to see.
Okay.
Yeah, I can't really add much to that, except to say that you talk about all the elements coming together to create a perfect storm. We're living it now. You know,
like it.
Look at what 1.5 C increase has wrought upon human society. What do you think 2 C is going to bring? It's going to be bad. And with the exponentiation that is taking place, and we know is taking place, I find it and then with the thermal inertia, I find it difficult to reverse course.
Okay. Well,
I'm not saying people shouldn't. I'm not saying people shouldn't try, some of the ideas that are being put forth.
It's gonna happen.
But
I mean, in 10 years, no matter what's happening, we'll be driving, or it will be an electric car market. It's going to happen, and I will say one thing. There might be problems, but I'm sure so glad Trump is not in office. That's all I have to say. And my ending thing will be, I will be doing a follow-up piece on Deb Haaland and the fight that's going to happen in her hearing, because she's just too good to be the head of the Department of Interior. So I will be doing a piece on that, and there's a lot. Jen and I will be on Sunday nights, and Nick Humphrey's going to start a once a month show that's going to correspond with his work. Every month he puts out a monthly report of what's fucked up all over the world weather-wise. I guess that's how I have to say it. And that'll be once a month, and we will have another State of the Planet. So I really appreciate everybody that came. It's been a long show. It was a good show full of good stuff. Don't forget, we have a little fundraiser going on. It helps keep the Wi-Fi going. It helps keep the subscriptions, the ability to make videos and all, and it is not for anything but that. And thank you. And Rick, you sent a link to the article. Okay, great. All right, guys. I say thank you. Peace out. It was a wonderful night. Goodbye.